Okay, I may as well make a start. Welcome everyone. My name's Glyn Hughes. I'm one of the admissions tutors for the School of Computing and Math Sciences. Specifically, it's my role to host open days and applicant days. So as I mentioned just before, we'll have a quick overview of the school and of the general courses and what we can expect from our degree programme upon its completion. And then later you'll have the opportunity to talk to the specific programme leaders about course-specific content. My contact details are there. By all means, if you want to email me afterwards about any general queries about the courses. If you have queries about the admissions process, it's better to get in touch with the actual admissions team. They have more information about UCAS and the application process. But certainly any questions about academia or the actual content of the courses, by all means feel free to get in touch with me after today, or of course just ask me or any of the other members of staff questions today. So the primary question, why study with us? It's a double-barreled question. I mean, why study a degree and then why study it at LJMU? Well, from the perspective of the School of Computing and Maths, first-rate academic and support staff, all our staff are research active. And that's significant because it means that the courses are informed by that research activity. Much of the research is groundbreaking, so it will, in many cases, be beyond what is commercially accepted at the moment. There'll be stuff which is just emergent technology, emergent principles. For instance, the cybersecurity course, which is our latest edition, is directly informed by a research group called Protect, which, to cut a long story short, is dealing with protecting infrastructure, specifically oil infrastructure in the Middle East. You can imagine if you had a cyber-terrorism attack and you shut down all of Saudi Arabia's oil fields for 24 hours, you'd have worldwide panic. So protecting these kind of assets and infrastructures becomes more and more important. And of course, everything is computer controlled these days. This is the notion of pervasive computing, where computing is literally integrated in every aspect of society and every aspect of our daily lives. We have a degree-long personal tutoring system. This means that upon enrolment, you'll be put in a group, I think it's about 8, 9 or 10 students, and one member of academic staff will look after you, basically across the course of the programme. If you had any specific concerns with a particular module, you would of course talk to the module leader, whoever was teaching that. But if you have any other wider concerns and issues, or just generally someone to liaise with from the perspective of the school, then your personal tutor is that point of contact. They'll advise you when your results are out, they'll talk about options, they'll help you with the application process and your placement year. And certainly by the end of the 3 years at the university, obviously it's a 4-year course, but 1 year is spent in industry, you will in principle know that person very, very well. And our computing facility is a first rate. We want for nothing in terms of hardware or software resources. We have our own dedicated laboratories, which other students and other schools are not permitted to use by definition. Being the School of Computing and Maths, of course, we have very specific requirements far beyond what another school would, certainly in terms of computing resources. We'll be able to see during the tour today, and some of the breakaway sessions will be held in some of these laboratories. One thing to note with degrees in general is that they're more and more becoming a standard as opposed to something that sets you apart. 20, 30 years ago, a degree was very unique. I mean, not many people had degrees, and it was quite a novelty. It got you shortlisted almost immediately. Whereas now, more and more people are starting to have degrees. And that means that when you have say a graduate position as a large-scale company, there may be 10 positions available, and they'll have 300 CVs being submitted, and 300 people who have degrees. It gets difficult to start a shortlisting process. So one of the things the university is aiming to do is add something else, extra value to your degree. We have long run a placement year. Not all universities do. Our placement year is compulsory. Students must undertake it. The placement year gives you what I like to call the 2 R's, recent relevant experience. You might have recent work experience, Burger King or something, but that's not relevant experience. Having a year in industry, particularly if you do well in that year, gives you a whole 12 months of experience. And companies like applicants to have some recent relevant experience, actually to have experienced what computing is like outside of an academic learning context, and actually in a real-world working environment where systems are actually designed, engineered, and deployed. The placement year is compulsory. They're usually paid, okay, which is obviously a benefit given the current financial arrangements. But the actual experience is far, far more important. And I'll talk a bit more about the placement year a little later on. About 5 years ago, we introduced what we now call the WOW programme. I always think that's World of Warcraft or Windows on Windows, but in LJMU, that stands for World of Work. This is a value-added component. It's not charged for and it's not compulsory, but you'd be a fool not to undertake it. It runs in 3 tiers. You have bronze, silver and gold running across the first year, second year and the final year. It's half a day a week, half a day to 1 day a week, which will fit around your teaching schedule. And what it does is it teaches skills, interpersonal skills and professional skills beyond the actual academic content of your course. So time management, conflict resolution, CV writing, entrepreneurship, all these kind of skills that develop you as an individual but are not specific to computing. And indeed, when you're working with other teams of students, you may well be with students from other schools, you know, School of Nursing and School of Biology and that. It doesn't matter anymore. The ability to write a decent CV, to time manage, to delegate tasks and to organise yourself. These skills are common across any particular discipline that the university teaches. You get a separate certificate at the end, the WOW certificate, and it is, particularly from computing's perspective, it is recognised by quite a few of the big players in the industry. Certainly IBM, Microsoft, Oracle, all recognise the validity and the significance of this extra certificate. It's a demonstration of your ability to be a young professional as well as be particularly bright in the actual academic field that you studied. And these two combined give you an edge. It means that you don't just present yourself as, I've got a first-class degree in computer forensics, I've also got these extra skills which I've taken the initiative to learn. Sometimes companies are as much interested in your keenness to engage with these kind of activities as they are with your actual academic content. Certainly I've known of situations in the past where companies have taken on academically weaker candidates, but simply because they seem to be more motivated and they seem to be more committed to their own development. Degrees, of course, maintain market value, so that's not specific to LJMU, of course, but those letters remain after your name for the rest of your life. It's a statement of intellect. It says, at this particular moment, at this particular place, you were good enough to achieve this qualification. A degree does not necessarily set you up for life. I mean, the degree is the start of your professional learning process. You will be engaging in lifelong learning till the day you retire, effectively. I did software engineering here between 1998 to 2002. I don't really, when I think about it, rely too much on the skills that I learnt in my degree. You know, I've had 10, 12 years since I graduated. And the skills you've learned since are what I draw on a daily basis. But a degree starts you on a path and it teaches you a certain mechanism of education. Specifically, it teaches you to be independent. Because when you graduate, you are expected to be the expert. People will be coming to you for questions. When you graduate and you go to a company and start developing software or working on systems engineering in general, you can't put your hand up anymore. There is no one to ask. You are the industry professional. So degrees, unlike sixth form or college, you're not spoon-fed. You will be a little bit in the first year, but certainly by the final year, the emphasis shifts to you. It's your learning. You need to research, investigate, and solve your own problems. Because by the time, in 10 years' time, when you get to my age, you'll have to fix your own problems. I can't ask anyone. You know, so some of the things I work on, I am the expert in the field. So this developing independence and this lifelong learning, you will never stop learning. A degree is simply the first 4 years of that process. Computing, of course, is a growth sector. It's never going to stop. This worries me sometimes because I think we're going to end up with Terminator or the Matrix or something. You know, we're going to destroy ourselves with computers. But nevertheless, computing is totally and utterly pervasive. If I take away the internet, if I take away your internet for a week, you're not going to be happy. Yeah, some people simply can't live. Some people can't live without Facebook for a day, let alone without the internet for a week. 10 years ago, I mean, not everyone had access to the internet all the time. It's truly amazing. Your mobile phone has more power now than a desktop PC did 5 years ago. It's truly insane. I mean, you dual-core processors in a phone. I mean, come on. I mean, if you just suggested that 10 years ago, you would have been laughed out of course. But nevertheless, this technology is getting more and more ingrained in our daily lives. And ultimately, we like the money. Let's not kid ourselves. We get a degree, we get a good job, we're a productive member of society, we make lots of money, we have a prosperous life. And that's why we're doing this in the first place, so that we can contribute to society, to our nation effectively, and we can also make some good money in the meantime. Generally speaking, you can expect an extra $500,000 over the course of a typical career, simply because you get into jobs you wouldn't normally have been able to achieve. You might get more rapid progression internally in companies with higher qualifications. Okay, so all our degrees are 4-year sandwich degrees, which means you spend 2 years in the university, a year out in industry, which is compulsory, and then the final year you come back for the fourth year, effectively, of the degree. Students are often, or some students are often apprehensive about the placement year, but the students who come back say it's the best part of the actual course. Some of them, let's say, they're usually paid, not all, some of them might be expenses only, but I think the record is somewhere in the 30s. Someone got paid £30,000 odd for the placement year. Generally speaking, you could expect around 12 to 13 at least. There's a couple of firms that will pay sort of 18, 19, 20. Some of the pharmaceuticals firms will pay up to £20,000 for the placement year, which obviously is a nice chunk of money coming in over the course of the 4 years. The academic framework is our guidebook, as it were. It's a very thick book with all the rules and regulations in it. If you ever have trouble sleeping, it's a recommended read. But what it does outline is the general structure of these programs. So everything is grouped into 12, 24 or 36 credit chunks. And you study 120 credits each year. So a total degree is 360 credits. This isn't the classification. This is just you need to do 120 each year. When you get 360, that's a complete degree. So the choice of programs, we have, first of all, if you like, the 3 original classics. It's worth noting at this stage, we're looking to, if we merge information systems into computer studies. So there won't be any leaflets today for information systems because it's not likely to exist in September. If you were considering IS, I would recommend moving into computer studies. Like I said, we're trying to combine those two. Computer studies is one of the longest standing courses. It represents, if you like, a good balance of all the different disciplines. It's particularly useful if you're not convinced or you're not sure which particular path, which particular area of IT you want to specialise in. Software engineering, I think it's the best, but that's because I did it. But software engineering is, if you like, again, it's one of the oldest ones in the school. And it's more technology oriented, hence the title. It's much more development oriented. So there's a lot more programming in general on that course. These two are some of the two oldest standing of the two. Just because they're old doesn't mean they're obsolete. I mean, these courses get updated massively every 5 years and incrementally in the years in between. Some fields of IT don't necessarily change that much on a year-to-year basis. So a course 1 year may be more or less the same the next year. But some modules will change quite considerably, simply because the speed at which IT actually moves. So some content will remain largely the same across year to year. Some content will be updated constantly. IT and multimedia, we can think of as being computer studies, but with a more significant emphasis on multimedia in computing. That's very relevant because pretty much any type of interface now involves the use of rich media. If you think back to old Windows 95 days and compare that to Windows 8, there's a significant difference in the use of advanced graphics in actually displaying information and interacting with individuals. Computer games technology, as the name suggests, is our computer games engineering course. This one is programming intensive. It's very similar to software engineering in that regard, and it is also quite mathematically intensive. There is a lot of maths in computer games. So if you're considering doing computer games and you don't like trigonometry, you might want to think again, because that bullet doesn't bounce off the wall by itself. That's cosine, tangent, cosine. So all that trigonometry you learnt at school, well, it does have a use. The bullets don't bounce off the walls, a ball doesn't bounce in a game all by itself. A lot of physics needs to be modelled there. Computer animation looks at rich use of animation technology and visual technology in computing. It's not really about making Toy Story. Okay, it's not an art course as such. It looks more at the scientific aspects of animation and rich media. Our two security-related courses, forensic computing. We were one of the first to set up forensic computing several years ago. Forensic computing, if you like, deals with reactive security. So when something has occurred, the investigations that thusly follow. If someone's murdered in a nightclub, one of the things the police will do, they'll check what their Facebook and Twitter accounts, and they'll seize their mobile phone. Because people are publishing their entire lives online now. So by checking Facebook, checking Twitter, and getting all the information off their mobile, they can pretty much paint a picture of exactly what they did and who they contact that evening. So the ability to investigate these kinds of occurrences becomes more and more significant because computing is more and more pervasive. When the Navy SEALs zapped bin Laden, one of the first things they did was grab all the computers in the facility, get all the information off, because everyone is digitizing all their information. Cybersecurity, I would mention briefly, we can think of as sort of proactive security, trying to prevent things from happening in the first place. So how do we write software that's secure? How do we secure networks effectively? How do we secure infrastructure to prevent attacks or problems occurring in the very beginning? So I've drawn a quick chart here that it's not definitive, but it helps us sort of place, in terms of theme, where these different courses lie. This doesn't specifically, it doesn't in any way relate to the difficulty of the course. All our courses are of comparable level of difficulty and comparable level of work is required to go into them. But they are themed. So computer studies very much in the middle. As you get more and more multimedia oriented, you go through IT and multimedia and then computer animation. The further right we go, we get more technical, so software engineering is more technical than CS, and games you can think of as being the combination of media and programming and development. Computer forensics moving into the security, and again cybersecurity being relatively technical but with a much more of an emphasis on the security side of the spectrum. We don't really go left, and certainly once IS has gone, we don't go left at all, because we do have the business school in the university that deals with this kind of thing. The School of Computing and Maths is more about the development and engineering of systems as opposed to their management. So, what kind of structure can we expect over the course of your years here? Lectures will vary in size considerably. At the moment, we have what we call a common first year, which there are two reasons for that, and I'll come to that in a moment. Class sizes will vary considerably. We have some massive lecture rooms. Most of the lecture rooms in the building are roughly about this size, so they'll seat about 30, 40, 50. Generally speaking, as you progress through the 3 years, your class sizes get smaller because you're getting more and more specific in terms of the actual course content. In the first year, you may find several courses are all doing the same module. So there'll be a large group of students in some of the modules. By the final year, you're very much broken into specific course modules, lectures specific to your individual program. So you will only be with forensic students, or you would only be with game students. We spend as much time as we can in labs because computing is a very practical topic. Some topics, of course, are theoretical, so there will be more sort of traditional lecturing. But much of the stuff we do is technical, it's hands-on, and we learn by doing far more effectively than just listening to someone prattle on all day long. So we spend as much time as we can in the labs, actually, with guided tutorials, various exercises, particularly when it comes to the actual development side, programming and the actual engineering of the various systems. Tutorials, drop-in sessions arranged as and when they're deemed necessary. The personal tutoring system, again, is there to support your learning, like I said, to give you someone as a primary point of contact throughout the course of the 3 years. We have group work, not exhaustively. Exams are of course individual, some coursework is individual, but we do have some group work. And group work is significant because it's unlikely you would be working alone. in industry. I mean, a typical computer game team working on a particular computer game title may be 100 people strong. You'll have 10 programmers and 10 graphic artists and 5 sound engineers and managers. You know, there'll be all kinds of people that you need to work with, delegate tasks, and organize yourself. The team that puts together Microsoft Windows at Microsoft numbers over 2,000 people are involved in actually putting together various versions of Windows. So very large-scale teams at different levels, and the ability to work with others is quite significant. Your own research and development, this is the crunch point. I mean, we have to work hard. I mean, degrees are not easy, they're not meant to be easy. There would be no point in doing them if they were easy. We do need to lead into this. This is your degree, and with the costs the way they are, you only get one chance at doing this. There was a time when you used to be able to start a course, and if you didn't like it, you could ditch it and switch to another course. I think those days are realistically gone. You get one chance to do this. You must engage. You need to be spending at least the same amount of time in your own private study as you do with actual contact, even more so. The first year, as I mentioned, there'll be some hand-holding in the first year because you're out of college and there is a different style of education. We're in higher education now. And the onus is on you to engage with the learning. We don't necessarily chase you nearly as much as you would in school or in college. The internet, it didn't used to be, but everything is on the internet now. I mean, it's just, you can't, I've never not been able to find something on the internet in the last couple of years. So the ability to investigate articles, read around the topics. Lectures will cover the skeleton of what you need to know. It's, the onus is on you as an independent learner now to develop your, put the flesh on the bones effectively. By the end of the final year, this is all about becoming an independent learner. So that when you leave, you have the confidence and you have the ability to say, that doesn't work, what do we do? Right, I've got a methodology to go about fixing this, and come hell or high water, I'll get this working. And that's something that we don't tend to see in students in the first year, but by the time you get to the final year, the onus is very much on yourself to engage with your own research and development. So we're very much used to, as users, looking at computers and thinking, wow, that's pretty interesting, that's nice. But we need to start looking about what goes on inside a computer. When a computer, that's Mafia 2. Again, if you showed someone 20 years ago that's what computer games are going to look like, they'd be, nah, don't think so. Yeah? I mean, I remember Cannon Fodder and Doom, and no, what was it? Wolfenstein 3D, and trying to get enough memory in my 286 so I could play Wolfenstein 3D. Still seriously addictive games, some of these really old 80s games, but to suggest that there's this level of engineering going into a computer game these days, you would have been laughed out of court a number of years ago. The amount of work that goes into creating these models, the amount of physics that goes into these games for accurate ballistics, accurate, having a car that actually feels like a car, behaves like a car, flight simulators. There's huge amounts of physics, the amount of sound research, the amount of graphics research that goes in. But we no longer need to look at this and think, wow, that looks really cool, I want to play that game. We should look at this and think, I wonder what light maps they used, and oh, I think that's specular highlights they're using there. And look at the technology that's going in. We need to start looking at things as engineers as opposed to just end users. Your mobile phone, it's insane what phones can do now. And again, we need to look at this and think, that's really impressive. How do we actually do that? Windows has completely abstracted the whole concept of having a computer. I remember in the old days having to, you install DOS and then you had to install Windows on 7 floppy disks, and then you had to fiddle around with memory to get enough memory to play your DOS games. Now you just put a DVD in, reboot a couple of times, and you're off. Everything is done for you. And the internet, of course, is completely abstracted how software is delivered. It's only a matter of time before everything is available online. That's a trend which is generally called cloud computing. We already have Google Docs. We have Office 365. I mean, Office 365 does everything Microsoft Office does, well, almost. How many more versions of Microsoft Office are we going to guess that you get on a DVD? I'm not so sure. Maybe 1 or 2 more versions they'll have in the classic sense. After that, it'll just be Office 365. It'll be the online versions that you pay a subscription fee, $2 a month or something, to actually access these services. But what it will mean is you'll only ever need a computer, a browser, and an internet connection, because you won't install software anymore. Everything will be available online through the internet. Even games now, the number of games that are being written in Flash And for those of you interested in games, we have modules in the final year that deal with developing rich 3D online games, but again delivered through the internet. What we're interested in is how things work internally. So we don't really deal with binary anymore. You'll be taught how binary works, but in the 1950s, that's how you wrote code. And that wasn't too bad, because in the 1950s, Pong was quite a stretch, you know, I mean, in terms of processing capabilities. You would never be able to write Mafia 2 in binary. You would be an old person by the time you actually finished coding. The complexity of software has increased, and because of that, so have the mechanisms for actually engineering it. We moved into assembly. And assembly, the computers will understand binary natively. I mean, that's all a computer does is crunch ones and zeros. Your Intel i7, all it does at its very heart is just crunch ones and zeros, or true or false, 1 volt or no volts. That's all computers ultimately do. Assembly is a higher level language. It is compiled into binary, and then the computer executes it. But we don't even necessarily, it's very rare to even find anyone using assembly now. Now we have top-level languages, high-level languages. This is a snippet of Java for Android, for an Android application initialization. Any and every Android application will have that code in it somewhere. Java is a high-level language. It reads as English. If you're not used to programming, that probably all sounds like utter gibberish, but it's far easier to write code in this level, and again, it will be converted and compiled into binary. We don't worry about writing machine code anymore. We write higher level language. It's halfway between English, halfway between what the computer expects. But when we look at an Android application, yeah, I mean, that is Android, so this weather and clock panel here will have that code in it somewhere. So we look at the actual beneath the surface. We look at the engineering underneath the application. Okay, I'll talk about the first year. The second year and the final year will be dealt with in the individual breakaway sessions. At the moment, we have a common first year. This may change slightly over the next couple of years. But there's two reasons we have this at the moment. Firstly, we need to get you all on the same song sheet. There are a set of skills that anyone would expect you to know, being a computer scientist. It doesn't matter what you ultimately focus on. I like to think of IT as being a pie chart. Okay, 50% of IT you should have a passing familiarity with. 25% you should be good at, and 25% you should be an absolute genius at. For instance, computer games, computer forensics, I would very much fit into my 50% passing familiarity. I don't specialise in those areas. Enterprise database development and e-commerce is very much in my genius section. I mean, that's what I do primarily. So it's important, but I still have an appreciation. I can still understand 3D mathematics. I could still write some DirectX and some OpenGL code if I had to. So people will expect you to have a common set of skills regardless of which particular aspect of IT you end up specialising in. And some of the modules here are aimed at that effect. Everyone should understand programming, and we should understand software development as well. We should understand the development process. Programming is just one of the stages in software development. You have analysis, you have the design, you have the implementation, then you have testing, then you have deployment. And a classic example of why the software development process is significant, I always like to mention, is the disastrous NHS system a few years back. I can tell you right here, right now, there was nothing wrong with that NHS system. It was absolutely perfect. Just didn't do anything it was supposed to do. The reason for that was they didn't really consult nurses, physicians or doctors in what they needed out of the system. The engineers just sort of ran off and built it. It's what we call, it solved problems correctly, but it did not solve the correct problem. Yeah, and there's a subtle difference there. It's like saying I want a machine to make sausages, and I end up with a machine that makes bacon. Best bacon you've ever tasted, wonderful, but I wanted sausages. Yeah? So it's important to understand that we need to correctly analyse requirements and design systems to do the right thing before the engineering process actually takes place. Web design, again, everything is going internet-based now, so in the first year we need to cover the basics of the internet, the basics of how websites are constructed. This is an exciting time now because of HTML5 and CSS3 are altering what was going to be capable in browsers. So this module also deals with human-computer interaction, which is designing effective interfaces. Another good example is Vista and 7. There is effectively no real difference between Vista and 7. Yeah, they're the same operating system, almost identical operating system. As a matter of confusion, Windows Vista is NT6 and Windows 7 is NT6.1, quite curiously. It's rather strange numbering conventions. It's basically the same thing. It's like XP and 2000 were almost exactly the same operating system. But why was Vista a bit of a failure and 7 was a roaring success? I personally never had a problem with Vista, but a lot of people did, and Vista's largely been deemed a bit of a failure. But 7, wow, you know, everyone loves 7. It's the same operating system. All they did was tweak the interface slightly. They altered how it worked. There's some very, very few actual differences between the two. But it's important to understand that it doesn't matter how good a piece of software is, if the mechanism by which users interact with it isn't up to scratch, then people get frustrated with it, they don't appreciate the capabilities of that software. So that's always a good example of why the interaction between the human and the computer is always quite significant. Computer systems architecture. We don't really deal too much with hardware in the School of Computing because that fits very much into the engineering. The School of Engineering deals with the hardware side. But we do need to have an appreciation of basically how computers do things. So you'll learn all the different numbering systems. You learn binary, you learn hexadecimal, you learn octal, all the different internal numbering systems. You'll learn how CPUs work. You'll learn how difference between parallel and serial architectures. Not a massive amount of depth, but it is important to have an appreciation. We are writing software. Software runs on the hardware. It's helpful if we actually have an understanding, a basic understanding of what hardware capabilities we have to play with. Computing Society, a relatively new module that deals with the uptake of computing, this pervasive computing, and it looks at how computing has impacted our daily lives and indeed all aspects of society. We work with computers, we sleep with computers, we play with computers. You know, absolutely everything we do, pretty much all the time, has something to do with computing. Computing in practice is a little bit different for each course. The first semester is general engineering principles. In the spring, in the second semester, you split off into course specific. And the idea for this, it comes to the second reason we have a common first year. How many of you are sure what aspect of computing you want to do long term? How many of you are absolutely adamant you want to do? That's only a quarter of you, maybe if that. I'll tell you a little story. When I did my degree, we didn't have any of the specific courses. It was just IS, CS and SE. And I did software engineering, being the most technical of the three. All I wanted to do was games. It was games, 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 games. That's all I would entertain doing. I got my placement year at Sony. I was working on PlayStation 2 6 months before it came out. That was a great placement year, but something happened. And I shifted. And I've done e-commerce and databases ever since. I've never looked back. I can't tell you why. I just shifted. But I was adamant for the first 2 years of my degree, it was going to be games. That was all it was going to be. And then I changed halfway through my degree. One of the reasons we have computing in practice is to give you a taste of the course you've engaged with and help you decide, are you sure you want to do this? Because you will be able to change with only a little bit of fuss at the end of the first year. You'll be able to switch program. At the end of the second year, you can't change. You're already locked on that path. And so it gives you a year to have a different taste of all the different aspects of computing and try and, or if you're undecided, try and help you decide. And if you're convinced at the moment, are you still sure this is the path you want to go on? So it gives you that little extra bit of flexibility. Finally, across the whole level, across all the levels, we're teaching methodologies and principles. So by the time you start next year, we're going to be teaching Java as the base language across all 3 years. Computer game students get C++, but everyone else will be doing Java. And the reason for that is it doesn't actually matter. We picked Java for just reasons of simplicity, but it doesn't matter because if you learn programming concepts, you can pick up any language that comes along. The programming languages I use on a daily basis didn't even exist when I did my degree. Well, they did, but they were very, very new. I do Java and C# most of the time now. Java was a baby, and C# was launched in the year I graduated. The languages I used at university, I haven't written a line of code for 10 years. But it doesn't matter, because I learned programming as a science, and any new language that comes along, for all eternity, you should be able to pick up with relative ease, because you'll recognise the structures and the concepts. It'll look a little different, but they all basically behave in the same way. And this is different from an enterprise course. An enterprise course would teach you a specific version of a specific language or a specific tool. Degrees use specific tools, and we keep them up to date, but on a CV, you don't say, well, I did Java for a year, then I did C#. It doesn't matter. You did programming, and then you did advanced object-oriented analysis and design. That's far more significant, because that is applicable to any language that might come along. Okay, this is a little way off, your final year project. This is your thesis or your dissertation. We call it a project because it has an engineering component. It's worth 23.5% of your degree, so it is very much a make or break component. It's a 36 credit module. It's a big module, but there's only a couple of lectures just at the very beginning to set you off. What you have is you'll have one of the members of academic staff will be your supervisor. So this year, as it worked out by numbers, every member of staff in the school had 8 project students to look after over the course of the year. And what you will have is maybe, it might just be 10 minutes a week, sometimes it might be an hour a week, depends how much you've got done in that week. But you'll have a weekly meeting with your supervisor. Your supervisor is not doing the work for you, your supervisor is guiding you on the effective, on sound research and sound development principles. You will submit a 15 to 20,000 word report, and it will have the complete process from start to finish. The beauty is it's a real-world R&D related topic, and you can pick whatever you want. Within reason, of course, it has to relate to IT. But this is your opportunity to do something that personally interests you. Many students relate it to what they did in their placement year. If they engage well with their placement year, they may do something that was relevant in the company that they were working. But it's your opportunity to do something that you're interested in, and your supervisor will guide you through the process of effective research and development across the course of the year. Particularly good projects can even serve you well in interviews. You know, there are examples of excellent work, and again, it is the largest single chunk in your degree. We have BCS accreditation for computer studies and software engineering, and British Computer Society is dedicated to furthering computing excellence. There's an additional certificate available with those too. We are looking to accredit other courses we're entertaining at the moment. Computer games is going to be skill set accredited, which is recognised by most games-related companies. So there's ongoing developments. Just because these were the first 2 we've done effectively, doesn't mean they're the only ones that we'll be looking for accreditation with. Okay, QAA, it's a bit like the Ofsted for schools, the Quality Assurance Agency, deals with higher education. They do periodic reviews. Again, it's a very, very thick document they produce. Again, if you finish the academic framework and you still can't sleep, read the QAA report. Some of the key points that came out of the last report were good teaching, learning and feedback standards. So obviously the actual delivery of our academic knowledge, the learning processes that we foster, and the feedback mechanisms, where you get detailed feedback. So you got a C. Why did you get a C? You missed this. This wasn't. This is incorrect, and this isn't sound design. This isn't good. This isn't. This isn't. So on and so forth. Very important to appreciate why your solution is not as good as a model solution, or not as good as an optimal solution. Tutoring support, again, excellent. Was commented on. This one's very significant. Lively response to changes in the discipline. IT is one of the fastest moving fields. It's important to keep abreast of its changes. As I mentioned, each of our courses goes through a massive restructuring every 5 years. It's called a revalidation. On a year-by-year basis, there will be updates made. There will be improvements and alterations, either just to give more detail or to shift the focus slightly within the remit of that particular module. And the learning resources. The combination of these last two, very significant. Up to date, everything is always up to date. A lot of the stuff is research informed, as I mentioned at the very beginning. So groundbreaking, new, relevant topics. delivered, with excellent facilities. I said, this whole site has just been renovated, and all our computing, I said, we want for nothing in terms of hardware and software resources. Okay, so the World of Work programme, as I mentioned, this is, it's not compulsory, this is value added, but it is highly advisable to undertake the WOW programme. There's a matrix here of all the various components it does, so there's the certificate, presentation skills. I mean, so many job positions now you have to make a presentation. In 1998, the idea of standing up in front of a group of people and giving a talk was mortifying, and I do that several times a week now. I don't even think about it. So the ability to have the confidence to do that is very, very significant. A lot of technical positions now, if you're tendering for projects or you're presenting for tendering, if you're presenting for internal project developments, general careers advice, entrepreneurship, employability skills, all the kind of things that are going to help you secure employment upon graduation. These things, along with the placement year, give you that extra edge, effectively, in terms of that huge list of CVs that a company needs to work through. One of the nice things, the mock interviews are very well received. You're given a fictitious job to apply for. A week later, you'll have an interview, and they record it. They actually record the process, and then they can play it back to you, and they'll go through. That was good, that was good. Why did you ask that? Don't ever say that in an interview, and basically gives you a bit of additional confidence. Because, of course, you get a dry run, effectively, with this. You'll be doing this in your placement year, so you'll go through the whole process of applying for a position in the placement year. Placement year itself, it is 12-month full year. During the second year, there is some support, and your personal tutor will be assisting you with this process. The university does hunt for job positions, so it's not, the onus isn't entirely on yourself to go and find positions. Many companies are quite keen to take on placement students. It gives them some young, fresh ideas, a bit of fresh blood. Like I said, most of them are paid, so the average last year was about 13,000. What's nice is that some companies even invite students to come back upon the completion of their degree, which is really, really sweet, because that basically takes away a lot of the stress of finding a job upon graduation. One of the students I supervised was working for British Aerospace. They said to her, get a 2 honour first and you're welcome back, and she did. She went back, just walked straight into a job immediately upon graduation. During the course this year, you will meet with tutors. There'll be phone calls, there'll be site visits, because you are still our students, and we do look after you over the course of the year. But basically, you no longer report to the university for that year. You'll have a line manager, and you're working in that company with a team of developers, engineers, whatever the actual content of that placement is going to be. And we have excellent links with industry, not only for placements, but for consultancy, for collaborative research. And indeed, there's quite a few employers who come back to us for placement students and graduates each year. So there's a list here. I've organised these into different categories. So you've got the big boys, if you like, some of the larger players. We had a chap on IT and multimedia a couple of years back who got on the fast track at Microsoft, and he's rising through the ranks. He spent the last 2 or 3 years in Redmond in the States at the Microsoft campus. I'd love to know what his salary is these days, but he's basically on the fast track through Microsoft. We've had a couple of girls a couple of years back, permanent positions with Oracle, the large data-based systems engineer. Computer games, Sony, very good link with. Started about 10 years ago when I did my placement, but we have very good links with Sony. They keep coming back to us for placement students. Playbox is a firm in the city centre. They started writing games for Wii, and I've extended from that. Pharmaceuticals, there's a lot of IT in pharmaceuticals. Eli Lilly, in particular, have taken students from us for 12 years now. They don't really entertain students from other universities. They just keep coming back to LJMU. Eli Lilly pay well. I think it's about 18 or 19,000 they pay. And that's mostly Java development, because there is so much computing and IT being utilised in the pharmaceuticals industry. You've got media corporations, sort of engineering firms, and then, of course, there's forensic-specific firms. Bearing in mind that the police don't have much of a budget for computer forensics themselves, they tend to outsource that to officially recognised companies and corporations to actually undertake forensic investigation. So what can we expect upon graduation? Well, obviously it does in some way relate to which particular course you chose to do, but you've got the early stages, so if you don't find that you enjoy programming too much, it doesn't mean you can't be involved in the software development process. As I said, there's the ability to analyse requirements and effectively design systems in the first place. Only then do you move on to the actual development and programming aspect. Databases. Everything has a database these days. I mean, Facebook is basically just a glorified database with a pretty front end. I mean, technologically speaking, Facebook isn't remarkable. It's clever the way someone thought of it and put it all together, but it's just a very big database with a half-decent front end. Games have databases now, pretty much everything. I mean, you think about any shopping cart, any online system, everything has data storage in some fashion. So there's a lot of development and a lot of money in database design and engineering. Everything is networked these days. Find me a computer device. Well, this thing isn't. This is the only thing I can think of in this room that isn't connected to another computer in some way. Everything is connected either wirelessly or through a wired connection to some other device. The ability for these devices to communicate with each other and do so securely, ever more significant. Forensics itself, again, you can become a forensic computing specialist, a security specialist with software or networking. You can, of course, go into lecturing. And then, of course, there is always further study. You might decide that you want to further with a master's or even into a research qualification. You may, of course, also find that you do quite a few of these things simultaneously. I mean, I do design, I do software development, I do databases, I do networks, I do lecturing, and I'm doing a PhD. So you actually may find you do several of those at any one particular moment. So, in summary, then. Constantly evolving subject. 10 years ago, you had the geek idea. I haven't heard anyone use that in anger for years now, because everyone has got computing capabilities. I mean, there was a time when you had a computer, ooh, you're a geek. But you've all got a computer in your pocket these days. So I literally cannot remember the last time I heard someone derogatorily put down someone who works with computers. It is so pervasive now that computers are everywhere, and if you're not engaged with computing technology in some way, you're actually slipping behind. And it is constantly evolving, very, very rapid developments. You'll never get bored with computing, because if you look back, every 5 years, things have shifted on considerably. There's always a new initiative, there's always a new drive. So things are constantly evolving. You do have to put the work in. As I said, this isn't meant to be easy. Nothing in life worth doing is easy. We want you to enjoy your degree by all means. Do all those crazy things that students do. Go, hit all the nightclubs and run away from the police and get in trouble and all this kind of stuff. But we also want you to work hard. You have to engage with the course. This is your degree at the end of the day. It's not ours. And we've got all the time in the world for you as long as you're putting the effort in. You need to meet us halfway. You need to put the work in. Our facilities on our friendly staff. Not all the staff are as friendly as me, but most of them are. I mean, we only have a couple of evil lecturers. And the career opportunity, the combination of the WOW programme, if you do it, or I should say when you do the WOW programme. The placement year, again, that gives you recent relevant experience, gives you personal and professional skills beyond the actual academic content of your course. Trainee positions, you can expect roughly about 25k, and then swift advancement. Most of the people I graduated with are in the 40s to 50s after sort of 10 years. So healthy salaries in relatively short order.